GN, GF, GA, G, all of that. What's up, everybody? What's up? What's up? We are live. What are we doing today? Same thing we do every day, Pinky. Try to take over the world. Are we live? We are live. Cool. The goal today is to keep digging into X402 and see where we can contribute where we can. If you haven't seen X402, head over to x402.org. You can learn more about it that way. You can also go to the GitHub, learn more about it that way, check the issues, submit a pull request. Here's a tool that we developed at PayAI, which lets you test your X402 merchant or client rather. So if you're making payments using X402, you can test against this server. Soon you'll be able to like even test the payment, adjust the payment amount, adjust the scheme that you want to use, etc. The really cool thing about this server, this merchant, is that it refunds you your money. So you can say, I want to test with sending 50 USDC. It'll send you that 50 USDC right back after it unlocks your content. So we're looking to do more X402 contributions probably over the next few days. My initial plan was to dig into this issue right here of bringing X402 to Solana, basically adding Solana support to X402. But we got some stuff hot off the press today from Solana X402 group that I'm in. So I'll be looking at this instead and seeing what the folks at Fairmeter are doing, how they're thinking about X402, if it satisfies this issue or not, or if it has its own implementation that makes sense, and perhaps either building on top of it or going out to build alongside it. So let's see what happens. I'm looking at this for the first time, same as you. So I may be quiet at some points, but I'll try to stay speaking so that it can so that we can kind of think out loud through it and get some raw thoughts down. I'll pull up one more thing from the X402 scheme, which is this diagram. This should kind of help us think through how things work. So let's see. Solana payment gated API system. As far as I can tell, there's no mention of X402 yet, but this is something that came out of it. So I believe it seems the intent here is to, let's read. System creates a Solana program that manages micropayments for API access. Here's how it works. Payment creation. When a user wants to access a protected endpoint, they create a payment transaction that transfers SOL. Okay. Creates a payment account, PDA, program-derived address that stores payment metadata, uses a unique nonce to prevent duplicate payments. So first is payment creation. Second is settlement with race condition protection. Excuse me. There it is. So settlement with race condition protection. When the server processes the payment, it immediately settles it using an admin transaction that uses a unique settle nonce. This is crucial for preventing race conditions. And multiple settlement attempts will fail because only one can successfully close the account. Okay, makes sense. Returns the rent from the payment account back to the original payer, who ensures each payment can only be settled once. So this is preventing the this is used to keep the buyer basically from spending twice or 3 times for the same resource, as far as I'm understanding right now. Uh, oh, okay. Ensures each payment can only be settled once. Rent recovery. The payment account requires rent to exist on chain. When settled, this rent is automatically returned to the original payer, so they only pay the actual service fee. Race condition prevention. The settle nonce is key to preventing race conditions. Yep. Example, create payment transaction. Example, settle payment transaction. Let's see these bad boys. Okay. So I believe this is creating the payment 9 days ago. Oh, wow. And this is settling the payment. Can we see anything? Yep, this is settling the payment. This is creating the payment. So the question is, why is a Solana program required for this? As far as I can tell, it's to store the nonces to prevent, to prevent the buyer from paying twice for the same resource. The other way this can be done is by having your own database as the facilitator that stores which client has paid for which resource. So if we go back to this little diagram over here, a big part of why the facilitator exists, one part, but it's actually going to grow to be much more. So just to explain this real quick, you've got your client, which is the buyer. You've got your server, which is the merchant or the seller. You've got your facilitator, who is going to help the server in a bunch of ways in the future. But for starters, it's going to make sure that the client doesn't pay more than once for the same resource. It's also going to make sure that the payment that the client made is actually valid and is of the amount that the server asked for, so on and so forth. The facilitator sits between the merchant and the blockchain. Imagine Stripe, that's your facilitator. Imagine PayPal. So they deal with the banks and they deal with all the payment infrastructure. And all you got to do as a merchant is just install a few lines, install like an SDK and add a few lines of code, and you're all good. So I'm pretty sure that's what's going to happen here as well. You're going to have facilitators that add value so that the merchant doesn't have to think about all the specifics of, settling payment. What if on one blockchain, or what if, a merchant wants access to Solana, Base, Ethereum mainnet, Arbitrum, Sui, and like 100 other chains. The merchant doesn't want to think about that. So that's where the facilitators come into play. So the proposal here, or what Fairmeter here is doing here with this program, is they're making one part of their facilitator, might not be the whole thing, but one part of it is storing some nonces on chain so that the client doesn't pay twice or more for the same resource. What do we think of this? Agree that it's nice to use the chain as a database. I don't think this is what most companies will do or most facilitators will do moving forward, because it adds, for multiple reasons. One, it's slower than a database. Two, it's more expensive than a database. Three, they might have to manage a different implementation for every blockchain that they want to support. So if a facilitator wants to like help you pay on, let's say Coinbase already has a base mainnet facilitator. Say they want to run a facilitator on Solana. They may choose to use this program, but they may also just store all of the metadata and stuff inside their own, in a database with a similar schema that works across blockchains or whatever. So that being said, I think it's a very cool idea. Let's explore it. Let's see how it's built. I think we might end up doing something else, but let's look into it. So, also just want to make sure everything that I just did was actually recorded. Cool. We're live. We are live. Awesome. 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 So, payment program. What do we have here? Huh? We got a Solana program. Cool. Tests. Okay. Yay, it's initialized. Let's see the program itself. Cool. So here's our main program. Got buy credits, consume credits, settle payment, create payment. So it seems like there's a credit system here that they haven't mentioned in the README. Potential improvement. Okay. So creating a payment. Takes the create payment context. Where are we at? Create payment. Create payment takes a signer, a receiver. Anchor made me add this. Well, a payment account. Okay. System program. What did Anchor make you add? Oh, that's the payment account. Gotcha. What's the seed prefix? Gotta check the state for the seed prefix. So seed prefix is just payment. And a payment account has an amount, nonce, payer, and a bump. Okay. We'll look at credit purchase later. Okay. So payments as a string literal nonce and the payer. Okay. Is the nonce a I think the nonce is just a global that just increases regardless of who the payer is, and then when it's combined with a payer, it's unique. Okay. So to create a payment, we nonce payer.key and a bump program instruction context gives it system program and transfer from the payer to the receiver. Where'd the receiver come from? I think in context, right? So and create payment. Oh, here it is, receiver. That's what anchor made you add. Gotcha. Okay. Makes you add the check because this could be passed in as anything, right? So it wants to make sure that you know that the receiver could come in and be any account. Mm-hmm. 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 Cool. So this creates a payment. So there are two steps here. First, the payment is created, and then it is settled. So let's read the settle instruction. Settle payment. Ooh, what's this admin pub key doing? Sir, what are you doing here? I guess that's the facilitator. So only the facilitator can settle the payment. Okay. Makes sense. So the off-chain part of the facilitator. Payment. The payment account. The original payer account. Excuse me. All right. So first the payment is created, then it's settled. That's fine. I don't want to get too into the weeds. Let's just understand what it's doing at a high level. I want to see what buy credits and consume credits does as well. So buy credits seems like it It tops up like credit balance for the receiver. Let me see, do we have the state here? Credit purchase amount, non-payer credits. Okay. It's a cool idea. It seems like credits will be useful for sure. Like imagine I'm a program agent, whatever, and I want to get a balance going and then just spend from that. And that's actually nice to have on chain. That's actually really nice to have on chain because then your facilitator is auditable and like yeah, the credits that you you were promised are actually there and everybody can see that they are there. So that part definitely makes sense to have on chain. Well, you don't have to have it on chain, but now you're putting a lot of trust in the facilitator. It should be minimized as much as possible, and like that's a value add in my opinion. Um, that's a value add, but the first part is is perhaps so like yeah, a customer might pay more for that, and that's useful. Excuse me. Um, Whereas the nonce might just be expensive. Okay, that's really cool. Thank you, sirs, for putting that out there. Let's check out Fairmeter. I don't know much about them. Seems like they're also creating a new repo for this and a new org. Seems like it's going to be a serious project. One, yeah, yeah, okay. Can look into it more later. So that's cool. I don't think it addresses this too much. So let's go over this again. I kind of wanted I might be biting off too much, but I wanted my goal for the weekend uh tonight, tomorrow night, the night after to be to bring this to life because it's just been sitting there and I don't know. It seems like people are trying to coordinate around it, but like not much is getting done. So even if it's ugly, I just want to put something out there and then see how it goes. Uh, one sec, I will read through that. But uh, Sorry, random ADHD. Just thought I had to get that out. So here's what's going on here. We want to add Solana support to X402. We'll read through this again. It'll help me refresh my memory as well. So to help expand payment rails for X402, Dark Research would love to add Solana support to the protocol. We're comfortable following the contributing guidelines. As a starting point, we'll implement the exact scheme support, which is, I think, the main one at the moment. There's another one that's going to be up to that's coming. We're open to input on implementation design specifics. The Solana ecosystem already has some payment infrastructure solutions that can be built on top. Solana Pay, Solana Actions. One thing that's cool from Solana Pay is they handle this double spend issue by including like an identifier for the payment. And that's pretty standard across merchants or across like payment solutions for merchants. So it's a good idea. It's the same thing as what Fairmeter is doing here with their nonce, on-chain nonce. So Edgar starts by asking a couple of questions. The current X402 implementation requires the facilitator to settle transactions. Is there room for client-side transaction settlement given Solana's speed, and this could allow the facilitator to verify by TX signature and support a faster process? That great suggestion. There's more on it later. SPL USDC support is likely the most interesting, but given X402 is designed to be multi-currency, we're happy to add other support. And I think that's also a good feature to have. So Eric responds saying a large reason the facilitator settles transactions is to prevent TX reuse. So without having to keep the state of which transactions have seen before, my preference would be to keep that paradigm. I don't think having the facilitator submit the TX versus the client should add much meaningful latency. Yeah, so Eric's saying the facilitator will store which TXs have been seen so that the merchant doesn't have to. That's my understanding here. SPL USDC would be great, but we may be able to support all SPL tokens out of the box with a few tweaks. EVM exact supports any token that implements EIP 3009, which is like authorization, transfer with authorization. Okay. In my head, Eric says, in my head, exact on Solana looked something like the resource server responds with token address, amount, fee payer address, pay to address. Client assembles a transaction and signs it partially, sends it to the server. The server settles it themselves or forwards it to the facilitator to verify and settle. Edgar responds, gotcha, happy to keep the current approach. Agree, should be able to specify token address with the asset field. He mentions legacy tokens and new tokens. It's the same, I think. Which one should be supported? On implementation, the steps you laid out make sense. Finally, for posterity, legacy V0. So what's the value of partial signing? Eric says their main goal is to allow the facilitator to pay the transaction fee so that the merchant doesn't have to worry about it. Makes sense as well. Makes sense. So Alfonso comes in with some good input as well. The facilitator must sign in order to pay fees. Some considerations for the design. The facilitator needs to do transaction introspection to make sure that the client isn't giving it some weird BS. Otherwise, a malicious client can compromise the facilitator by adding some malicious transactions to sign 100%. Handling blockchain expirations and retries makes sense. Sharing smart wallets, work with the facilitator. Also a good consideration. Handling the case that the server side doesn't have a token account open, or requiring a token account to be open. Yep. Handling priority fees. An ideal design lets the facilitator set these at the time of sending, but it wouldn't be possible if the transaction is partially signed by the client. True. Next best approach may be to have the facilitator send recommended parameters so that the resource server can send those to the client. And this is a good idea, which leads to another great idea coming up soon. As a bonus, with high rent costs needed to open a token account, we need to support ZK compression down the line. Probably not a V1 item, but true. Agree. Cool. And then John Wong comes in with some great input as well. Large reason that the facilitator settles transactions is to prevent TX reuse. This is what Eric was saying. John says this is already addressed with transaction signatures on Solana. Deduplication happens at the validator level. We don't use nonces, so there's no state management on the side of the facilitator. They can just crank out pre-signed transactions that require a second signature from the sender for debiting the token account. So basically, the idea here is that the facilitator creates the transaction, and then the client or the wallet or the user, the buyer, signs it, and then it can go through. It can debit their token account. For this one, probably fine to assume that the merchant or the facilitator in a separate step opens up a token account for the merchant. I think the onus is on them anyway. One-time setup fee agreed. Handling priority fees. Ideal design lets the facilitator set these at the time of sending, but it wouldn't be possible if the transaction is signed by the client. Since the assumption is facilitator is paying for gas, then the facilitator should also send a fully pre-signed transaction covering relevant base and priority fees. End users just need to sign for the debit of the transaction and send it, and return the transaction signature to be verified by the backend. This also addresses the scenario where a facilitator is being asked to sign unknown transactions, since the facilitator is the one surfacing yes and no. So then this puts the onus on the wallet to verify that the facilitator didn't do something malicious. I don't know. Let's think about the real world. Who makes sure they're not getting scammed, the buyer or the seller? Typically it's the buyer. You know, you go to the market, the merchant tells you it's $100, or it tells you it's 50, tells you it's $60. You give him 100, he returns 40, or he returns 60, or he returns 50. It's on you as the buyer to verify that you got the right change back and that they only took what they asked for. That's true. It's on the client. However, the merchant is there. The merchant has more to lose in terms of reputation, because they're there long term. As a buyer, you might just be passing through once, whereas the merchant is there long term, and if they develop a bad reputation, eventually people stop using them. So yeah, I think that makes sense. And it does seem like the cleaner design. It also fits well into current crypto design as well. Like, you'll see more and more these days, wallets are looking out for you and making sure that you're not signing something malicious. Like the wallets, I think in terms of current infrastructure and code, the wallets definitely have more of that introspection built in rather than merchants. Okay. Payment required payload can look identical to the Solana Pay transfer request, which denominates a mint destination amount reference key, which provides, this is the nonce that Fairmeter is suggesting to put on chain. So this payment required comes from the server, but actually might be coming from the facilitator, which provides enough information for the client to handle settlement. So if the facilitator is going to be the one settling, they will probably suggest the priority fee, etc., pass it on to the server. And that can happen in this initial round trip. Adds a little bit of latency, because the client is going to request a resource. The server is going to say, you haven't paid me yet. But before it says that, it's going to go, it knows that you haven't paid yet. It's going to go to the facilitator, which sits in between, says, hey, pay me. Or, hey, give me, create a pre-signed transaction requesting this payment of the token, the destination, the amount, and a reference key. And also add in there like priority fee based on your current knowledge of the state of Solana. This goes out to the client in the payment required header. Client simulates it, makes sure nothing malicious is happening, signs it, sends it. And then calls out again, get API, but this time has X payment header. And in the X payment header, puts the completed transaction, like the settled transaction signature. Server verifies that it's finalized, or the facilitator verifies that it's finalized, comes back and says it's all good, and opens up then the server ends up unlocking the content to the client. Wallets increasingly handle transaction settlement because nefarious servers, dApps, can opt to front-run user transactions, so having settlement out of band of the server is slightly safer. Here's what it could look like. The gasless version is slightly more complex since we don't know which token account to debit from. Makes sense. So in that flow, the payment required payload has an endpoint to retrieve the relevant transaction by sending a post account to retrieve a serialized transaction. Gotcha. Yeah, so in the gasless version where the user isn't paying for the gas, the server needs to know where it's going to get, like, which hmm. The gasless version is slightly more complex since we don't know which token account to debit from. Well, how did we know over here? I thought that was known ahead of time, where payment is being made from. Isn't the server telling the client which token account to debit from? Oh, I see. We don't know the client's, yeah, we don't know the client's address ahead of time because they don't send it in this first request. So, so if the client is signing, it's fine. If the client is paying for gas, rather, it's fine because they're going to include that. But if the server is paying for gas, then it needs to know the address of the client so that it can, yeah, it can pay for them. So here the client sends their account, the server then creates the transaction, and then it gets simulated to make sure nothing bad is happening, signed, and then sent, and then sends the transaction hash in the response. The server verifies transaction inclusion, sends TX confirmed. Uh, so Eric responding to transaction deduplication. So Eric says this isn't actually about the chain, it's about the client being able to claim a payment has been made that was made in the past. So like not reusing the same payment. But that's what this reference key here is for, or the nonce. In the send TX signature scenario, an adversarial client can make multiple requests with the same signature that was processed on chain previously to get repeated resource access. If the facilitator or server isn't submitting the TX, one of them needs to store state of what has already been seen. If the facilitator or server is submitting the TX, they know for a fact it's a new transaction. Makes sense. Seems reasonable so long as the client implementation has logic to verify transactions are as expected. Blind signing a request from a server also seems bad, but I think that's the way wallets work today. Facilitator propose, client confirm, legit, and partially sign. Facilitator broadcasts. Seems like a good path here. Here I am saying I'd be happy to help. Refactor the entire protocol to follow facilitator-driven transaction construction. Update the spec to include another field for the facilitator to return a partially signed or C require extra step in the flow. I see the intention here, but we either need to A, refact the entire protocol to follow facilitator-driven transaction construction, B, update the spec to include another field for the facilitator to return a partially signed transaction in case the client wants to pay with Solana, or C, require an extra step in the flow where the client requests a partially signed transaction after being given the 402 response and indicating to the facilitator that they prefer to pay with Solana. Open to these options, but for simplicity, we'll put up a PR that follows client-side TX construction first and go from there so we have code on the board. Good point. Could the client not check the transaction they've received to see what programs are being called with which values? Yes, it can. That would be my preference here, as the client can then make an informed decision. In this scenario, the resource server would include a transaction to sign in the extra field of the payment requirement objects, meaning still one half. Yeah, cool. All right, BRB guys, gonna wee. It's wee time. Gonna order food real quick. I don't want to eat just yet because I don't want to get hungry. But just gonna order it. Give me a minute. Grab. Gravity, gravity, grab. What to eat? What is a man to eat at this hour? Would remind me of kebab. Banging bonds. I'd love to put some Jay-Z on the stream, but I think we will get muted. So can't be doing that. Can't be doing that. No, sir. Damn. All these options suck. Sorry to say. But nothing is speaking to me. Queen's Kebabs it is. Or is it Nina Cafe? Where are you at, though? Nina Cafe and shawarma. I don't know, man. I want a different shawarma place. All this shawarma ain't that good. King Kebab shawarma. Chef Kebab shawarma. Falafel shawarma, that could be good. Gulp. All right, let's try this one. New spot. My home. Chicken shawarma sandwich. Please don't disappoint. Oh, shit. Nice. We'll have to take the GF to this place if it's good. They got all the good stuff. All the goodies. Oof. They got the cheese rolls too. My goodness. All right, please don't disappoint me. I will be so happy if I just discovered a new banging spot. Damn, Grab giving me all the discounts. I didn't even ask for anything. They just put like 10 discounts on my plate. Yes, and another one. All right, that's better. That is better. I am now paying $8 for a sandwich in Indonesia. This is wrong. This is haram, as they say. How are you paying $8 for a sandwich in Indonesia, my guy? Come on. All right. All right, all right, all right. Um, hmm. So the race condition is what happens if a merchant says you got to pay $10. The client signs and sends the transaction. Then somebody sees that this transaction that a transaction was made for X amount. Um, transaction was made for X amount. So here's, sorry, went inside my head. So there's a concern about a race condition, especially if the client is broadcasting the transaction. So in the situation, like let's say we just read all of this and we're going to go ahead and let the facilitator um, let the facilitator let's say the facilitator or server is going to propose the payment, and then the client simulates, signs, sends the transaction, broadcasts the transaction, right? And then so if the client broadcasts the transaction themselves and then they send the transaction signature to the server to verify, like I could be squatting on some merchant's wallet, and I'll be like, all right, somebody just paid. I'm gonna take that transaction signature. I'm gonna send it to the server and use up that resource before the actual client sends it. That's the race condition here. How do you prevent that? The first thing that comes to mind is, let's say the server actually settles as was proposed initially by Eric. All right. Excuse me. Server settles. It's still here, by the way. Like this, there still exists a tiny window where actually no. So the server settles on chain. So the facilitator, rather, like the server trusts the facilitator to settle and not give the to settle the payment and then let them know that it's been settled after the transaction confirms. And then the server unlocks the content to the client. So does that solve the race condition? If a server settles, and they say, hey, the transaction would for this payment, reference payment, whatever, has been settled. You can now unlock the content. Well, that makes sense. So how can the facilitator be tricked in this scenario? Can another server send them a Can another server send them? I guess that's why you need an API key with the facilitator. So then you auth with the facilitator and you send them a like a bearer token, and you say, hey, here's my bearer token, settle this transaction for me with this reference number or with this nonce or whatever. Facilitator settles it, confirms the transaction. Yeah, like these two are the same thing, right? And in this scenario where John is suggesting that the client signs and broadcasts the transaction, it's possible that after the client broadcasts the transaction, only then yeah, this can be done. I mean, it can still be done if the client can sign something. So instead of just sending the transaction signature, because anybody can send the transaction signature. They would send the transaction signature as well as another signature that only the client can create, like a signature of the transaction signature signed by me, right? And then the server can validate it. I wonder if is there room for this X payment to have an extra field or something? Probably. Yeah, I don't know. That seems to be a flaw here. So let me see what the spec says about the X payment. I know definitely not the most educated, but we have considered adding an extra key to the response return from verify. Extra field of the payment requirements. Hold on, I gotta read some messages. So like here, I'll give you all some music while you wait. So we're back. Was just thinking through potential attack vector with this approach. Excuse me. Why am I incognito here? Let me open up a new tab. Get all these bad boys in there. That's a lot. BRB. We're back. So yeah, what happened since? Basically, so let me look at this. Let me look at the. Seems like what Eric was suggesting is client implementation verifies transactions, facilitator proposes, client confirms and signs, facilitator broadcasts. Facilitator broadcasts, and is this still the same hop? So facilitator, so payment, this payment required has a facilitator proposed signature. The client inspects it, sees that it's good, partially signs. All right. The facilitator settles it. And that prevents what I was saying. That prevents that race condition. However, there's one. So how many extra steps are we doing here? Request to server. Server requests to facilitator. Right? So like we already added one step here. Some latency. Introspection, not broadcast yet. Introspection signing, comes back here, comes back here. It's settled. Confirmed. Settled. Response. So we're adding one extra step here and one extra step here. If we care about speed, it does get broadcast here. And as soon as it's broadcast, the client sends verification or proof. And then this happens. Be slightly faster for sure. All right, let's read through it a little more just to see what's being sent in the. If you ask me, I feel like it's up to, like, if there's something that we all agree upon, it's this flow right here between client server and the headers and the, so the status code payment required, then including either the payment or proof of payment in the X payment payload, and then the X payment response payload coming back. The data that's in here can be arbitrary. Like it depends on the chain, depends on the implementer, but payment required should definitely have like the receiver, at the very least, the receiver and the currency they want to get paid in and the amount. All right, let's read through it a little more to understand what data is being sent. Where can I see the scheme? I guess they're here. So the payment required response payment requirements. So the X402 version, would they accept? And then error and processing payment. Okay. Payment requirement is the scheme, like exact, up to, etc. The network. Maximum amount required to pay for the resource and atomic units of the asset. URL of the resource to pay for. Description of the resource. I don't know why these are necessary, in my opinion. They are, I mean, the client already knows all of this. This is required. Everything else is extra, in my opinion. Like, if you want to standardize on that, I don't know. Okay, it's good to read them though. Gonna eat real quick. BRB. Sorry, but it smells too damn good. Oh my God, that food was so heavy. I can literally feel it sitting in my stomach. Not digesting. Jeez. Why? Why did I do this to myself? Classic, man. Classic. When you eat more than you're supposed to, or you eat something new, it turns out to be too heavy. All right. Hopefully, I don't fall asleep on stream. Thank you, sir. So here's what I'm thinking. I want to go through. I want to go through this data, these payloads, and then, excuse me, then look at the SDK. At the X402 scheme. Perhaps add Solana to it. Maybe just look at it and understand it. We could do more of the adding Solana work tomorrow. So let's just look at this and then try to understand it to see where we would fit the pieces, as they say. All right. So the payment required response, we'll send this in the response body. Okay. And our requirement is scheme network maximum amount required to pay for the resource and atomic units of the asset. URL of resource to pay for, description of the resource. MIME type of the resource response, output schema of the resource response, address to pay value to, maximum time in seconds for the resource server to respond. Address of the asset. Extra information about the payment details specific to the scheme. I feel like this extra can just be extra information about the payment details specific to the scheme, specific to the network. For exact scheme on EVM network, I expect extra to contain name and version pertaining to asset. Okay. Payload is scheme dependent. Okay. Facilitator types and interface. So a post to verify verifies a payment with a supported scheme and network. Payment header, payment requirements. What is payment header? Where else is this mentioned? Okay. I would even say the scheme this payment required response. I would say you can have the version of X402. Sure, accept. And then this payment requirement. Should have the scheme and the network. And perhaps the address and the asset, but that could also be added to the scheme. So the scheme, for example, would be, or the network would be, let's say Bitcoin, scheme is payment channel up to, or payment channel exact. Like the scheme could even have the network with it inside the, and then everything else goes inside scheme dependent. Scheme dependent, whatever object or requirements. There could be a scheme that's just donation based, right? The client will say, send me whatever token you want. Scheme could be like Ethereum donation. Like Ethereum donation. Yeah, scheme could be Ethereum donation. And then inside the scheme, you've got a network, perhaps just an address. It could be any asset. Yeah, that's my opinion. Scheme data. Scheme data is just an object. It's like a version. It's a version within a version. It might be making it too abstract, but maybe not. And then in Solana, you can have different schemes. Like I've got facilitator-driven scheme. I've got a client-driven scheme, whatever. And by specifying the scheme and the request and the response, that gives you all that you need to know for how to construct it. This is kind of a big suggestion. Maybe they'll do it, or maybe wait until it's a little more mature and there's more support for it. Am I on this thing? Yeah, I am. Look at me. Notorious. Nice. Let's go, Notorious. Guess this counts based on number of commits. Who's added the most code? And who's the deletor? Nice. I think that's a better way to structure it. If I had to give 2 cents. Let's see, specs, schemes, exact, scheme, exact EVM. So the X payment header, payload field of the X payment header must contain the following fields. So this is the payment being made. Signature of the transfer. Oh, there you go. Oh no. Okay. And then the authorization itself. Yeah, that makes sense. This allows yeah. Cool. So this is in the header. I don't know, do headers send JSON usually? I guess it could be whatever you want it to be. It's base 64 encoded. Right. This one, verify nonce is not used. That means there's got to be a database, whether it's the blockchain or internal. Excuse me. Mm. All right. Getting tired. This is an interesting issue. All right. All right, I think that's enough for today. We'll wrap up and then hit this again tomorrow. Let's see what comes out of it. Um, appreciate you all. Much appreciation. Out of that session, mainly digging into how to bring X402, how to help bring X402 to Solana.